All right, so now we're going to look at an example breaking down a parallel circuit. Well, we'll use a similar circuit we did for the first part in series, but now we're going to put them in parallel. Look at what happens to the current flow in it. So again, here's an example for a parallel circuit. All right, so I'm going to build the same circuit I just did. You have a supply voltage. Vs, we're going to say is 10 volts. We're going to come out of there with some current. It's going to split. You've got one pathway here. Here's another pathway. And here's our third parallel pathway. And I'm going to tell you that R1 is equal to 2 ohms. R2 is equal to 5 ohms. And R3 is equal to 13 ohms. So these are the same resistance we had in the last example problem. And there's going to be a voltage drop and a current associated with each of these that we don't know. All right, voltage 2, current 2, these are unknown. And voltage 3 and current through 3 that we're trying to fill in. We also want to know our equivalent resistance if we're breaking down a circuit. And we want to know our total current that leaves the battery. All right, so those are some of the unknowns here. And so since we have all the resistors, well, let's start by finding the equivalent resistance. All right, so step one, we're going to find Req. And our equation for Req, well, Req is using the inverse of these inverses, right? So 1 over 2 plus 1 over 5 plus 1 over 13 would be the equivalent resistance. Now, here's where this inverse function is helpful. Rather than trying to do all of these division problems, like if I had my cat, it'd be 1 over, and then I'm like 1/2 plus, and look at all these parentheses I got to be careful with, right? And some of your calculators are going to have a little bit more clean features and show you it in there, but I got to make sure I include all the parentheses. I get that value right there. All right, so that ends up becoming the correct value, 1.29 ohms. It's actually a really low resistance, right? It's actually lower than the quickest one, right? So it actually helps traffic flow by opening up an extra lane, or in this case, 2 extra lanes. It's going to speed things up. So really low resistance. Now, another way to do this equation in your calculator that I'm going to show you, which will be helpful, we're going to use the inverse button, which looks like this. All right, this means taking the inverse or flipping it under the denominator. And when I use my calculator, I'm going to do it this way. I'm going to do 2 to the inverse, right, plus 5 inverse plus 13 inverse, and then inverse the whole thing. Right, so what I usually do, you can either do it all in parentheses right here, or I'm just going to go 2 to the negative 1 plus 5 to the negative 1 plus 13 to the negative 1. I'm going to hit enter, and then I'm going to take the inverse of that answer, because that's my denominator, and I get the same value. Or obviously I can do in parentheses 2 to the negative 1 plus 5 to the negative 1 plus 13 negative 1, close the parentheses, and raise that whole thing to the negative 1. That will also get me the value. All right, so as you can see, it's a really simple way to find that equivalent resistance using that inverse function. A lot easier than putting all those things in denominators in fractions. All right, so we're going to do plenty of practice with finding those equivalent resistances. All right, but nonetheless, we found the equivalent resistance, and now our work is pretty much done for us. All right, we know already that because they're in parallel, these all get 10 volts. And Ohm's law says that I equals V over R. So this should get 5 amps. 10 divided by 5 is 2 amps. And 10 divided by 13 is a fraction, right? 10 over 13 is 0.77, 0.77 amps. Less current goes through that third one than any of the other ones, right? The lowest resistance is the 2 ohms, so more cars, 5 cars per second versus 2 per second versus less than a car every second goes through that last lane. So we know 1.29 ohms. I total is going to be, we can calculate it now one of multiple ways, right? I total is equal to the supply voltage over the equivalent resistance, which is going to be 10 volts over the 1.29 ohms, and that's going to give me a value. So if I go 10 divided by 287, I get 7.77 amps. Or I can add up I1 plus I2 plus I3, and look at 5 plus 2 plus 0.7 is also 0.77 amps. You end up getting the same answer either way. So again, using Ohm's law over and over again, I get 7.77 amps. Right? A lot higher current in this circuit than we got in our one here. I only got a half an amp through this circuit when those same toll booths are arranged back to back. Well, now if we arrange them where they're separate pathways, all right, it's being a little goofy on me here, we see that that current flow goes way up. When you enter that highway and you got the option to pick your lane rather than hitting all three booths, you're really only hitting one because you can jump into different lanes, and therefore the flow of those cars down that highway are going to be significantly faster, which is why you see all these toll plazas keep adding parallel lanes to pass through to help the flow. And they try to speed up those lanes by adding easy pass lanes. Hopefully this helps.